Hey everybody, it's the 2018 FRQ number 3. So on here we're given the graph of g, which the graph of g is a continuous function. It's the derivative of the function f, which really means this is the graph of g and g is really f prime. So the function g is a piecewise linear function between -5 and 3, and then it's this quadratic function between 3 and 6. So that's going to be important when we do one of these problems. So in part A, it just says if f of 1 equals 3, what is the value of f of -5? Well, they gave us the graph of g, which is really the graph of f prime, and they're asking us to find a function value for f. So we're going to need to use this initial condition that they gave us to find that out. So to find f of -5, we're going to use f of 1, and we're going to do the integral then from 1 to -5 of g of t dt. And remember, g is really f prime, so I guess we could write it as f prime of t dt. Either one would be totally fine. Okay, so let's see what that means. So f of 1 is 3. I'm going to flip that integral around, so I'm going to make it minus the integral from -5 to 1 of f prime of t dt. And we know that really just means find the area between from -1 to 5. No, -5 to 1. I know my numbers, guys, it's fine. All right, so -5, let's see. We've got this trapezoid down here, and then it's flat, there's no area, and then going to 1, we've got this triangle. So we have a negative trapezoid and we have a positive triangle. So let's write that out. Let's see. It's going to be 3 minus, and let's do the trapezoid first. So it's negative because it's underneath the x-axis. The height of the trapezoid is 3, so it's going to be 3 over 2. One of the bases, let's see, this base here is -5 to -2, so that's a base of 3. This is a base of 4, so that's going to be 7. And then we're going to add that positive triangle. So 1/2, the base is 1, and the height is 2. So let's see, that becomes 3 minus, it's going to become -21 over 2, and then plus 1. So let's see, 3 plus 21 over 2 minus 1. So it's really 2 plus 21 over 2, so 25 over 2. So f of -5 is 25 over 2. All right, so for this problem, this was worth 2 points. So it's 1 point for actually writing the integral, or for using the initial value, excuse me. So did you remember, or did you know how to use this f of 1 and that 3 there? And then it's 1 point for your answer. All right, part B here asks us to evaluate this integral from 1 to 6. So let's take a look at our graph before we do anything here. I'm going to erase what's on here so that we can focus a little bit more on exactly what we want. So we want the area that's trapped from 1 to 6. So starting at 1, which is right here, and then going to 6. Well, the thing we have to remember is that we've got this quadratic from 3 to 6. So the first thing we're actually going to do then is we're going to stop integrating at 3 and do just this rectangle, or really it's a square, right? 2 by 2. And then we're going to do the quadratic. So The very first thing we want to do here then is we're going to say, okay, let's do the integral from 1 to 3 of g of x dx. And then we'll add the integral from 3 to 6 of g of x dx. And so the area from 1 to 3 we could see was that square that I filled in there. So 2 by 2 is 4. Plus, now we're going to do the integral from 3 to 6, and we're going to put in the function that they gave us, which was 2 times x minus 4 squared dx. Because now we can't use area to find it since it's this quadratic. We're going to have to actually take an antiderivative. So let's see, this is going to be 4 plus, and now we're going to do an antiderivative. So if we add 1 to the exponent, that's going to become a 3. There's already a 2 out front, so if I divide by 3, it becomes 2/3. And luckily, there's no chain rule going on here because that x minus 4, the derivative, would just be 1. So there's no chain rule that we would have to account for. We could use some u substitution, but it would just be an extra step. It would be unnecessary. So then we're going to do plus c, and we're going to evaluate from 3 to 6. All right, so let's see then. We're going to get 4 plus, now we're going to plug in 6. So it's going to be 2/3. 6 minus 4 is 2 to the third is going to be 8 plus c minus, and it'll be 2/3. Let's see, 3 minus 4 is -1 to the third is -1. And then let's see, so 4 plus 16/3. We know the c's are going to cancel out. Excuse me. We know the c's are going to cancel out. This is going to become -2/3, but it's minus, so it's really plus 2/3. So we get 4 plus 18 over 3. 18 over 3 is 6, so we end up getting 10. So the integral from 1 to 6 of g of x dx is equal to 10. Oops. Okay, so for this one, this was worth 3 points. So it was 1 point if you remembered to split the integral at x equals 3, right? So doing this part right here, that was really worth a point. It was 1 point for your antiderivative, and then 1 point for your answer. All right, moving on to part C, we want to know where the graph is increasing and concave up. So remember, this is the graph of g, but g is really f prime. So we want to know if when f is increasing, so we're looking for f prime being greater than or equal to 0, and then when f is concave up, so we're looking at f double prime being greater than 0. And we know that that means the slope of f prime is positive. So let's see then. We want it to be increasing and concave up. So we want to be above the x-axis and have a positive slope. So above the x-axis with a positive slope. So 0 to 1 and from 4 to 6. So f is increasing and concave up. On the interval from 0 to 1, union with 4 to 6, because f prime, which is equal to g, is greater than 0 and the slope of f prime, which is g, is positive on these intervals. This was worth 2 points. It was 1 point for your intervals, and then 1 point for your reasoning. And last but not least, here in part D, find the x-coordinate of each point of inflection. So remember that a point of inflection means we're looking for where f double prime changes sign. And we know f double prime really means the slope of f prime, which is g. So we're going to be looking for where does the slope on this graph change sign. So let's go ahead and get rid of these markings that are here. And we're going to be looking for where the slope changes. Well, it's 0, then positive, then 0, then positive, then 0. But then from here to here, it's negative. The slope is negative. And then the slope changes to positive. That's the only place on the graph that the slope actually changes sign. So it's at x equals 4. So x equals 4 is a point of inflection. Because the slope of f prime, which is g, changes from positive to negative, or sorry, from negative to positive at x equals 4. And then this was worth 2 points. It was 1 for your answer, so for getting x equals 4, and then 1 for your reasoning. And remember on both of these that I just did, your reasoning, you have to connect what you're talking about back to what we were given. So that's why it says f prime equals g on all of these, because we were given the graph of g, so we have to make sure our answer shows that we're talking about it. Thanks for watching.